right, good day, everyone. Happy post Memorial Day. Test 3A. Go through these problems with you, for you, and determined what you did right and what you did wrong. So let's start with the first one here, and what we're going to do is get these denominators to be the same. So I have to multiply top and bottom here by 4 over x. And 4 over x top and bottom. What did I do here? This thing is confusing me a little bit. So that would be 4x over 4x. And that would get me to be, the denominators would be 4x squared. In the top I'd have 8x plus the 5. 8x plus 5. So there's number 1. Okay, how about number 2? Number 2, these are opposites, so this could be read as multiplying the top and bottom to get them to be the same. I'd multiply by negative 1 over negative 1. Do it this way. Just working on that second fraction. So now what would happen, I'd end up with f minus 3 in the bottom. That's not a problem. And then the top, this is negative 1 times negative 1 here, which is positive 1. So therefore, I'm going to have 1 plus 1, which is 2, over this f minus 3. Okay. And this is 7 over x minus 2 over 1. Let's get the top and bottom to be the same. So it would be x minus 2 over x minus 2. Therefore, I have x minus 2 in the denominator. And then my top here, I'm going to have 1 times x minus 2 is x minus 2. Okay, so this is gone. So then I've got 7 plus x minus 2. So at this point, I can call this 7 minus 2 is 5. So I'd have x plus 5. And that's how I get that numerator. How about number 4? Get these denominators to be the same. So I'm going to multiply these denominators by each other. So for example, this one I'm going to multiply by x minus 4 over x minus 4. And I'll just do that with that binomial. And what else? This x minus 4 I'm going to multiply by x minus 10. And again, top and bottom are the same. Okay, so I see my bottom is going to be x minus 4 times x minus 10. And then my top here, I've got a lot going on here. So let's see what I did. The first part here, it's going to be 2x squared. 2x squared minus 8x. And then this is the minus sign. Remember, we're subtracting this. So this is negative x times, and I'll do the distributive property here. So this is going to be negative x times x, which is negative x squared. And then negative x times negative 10, which is positive 10x. Okay, here's where we're at thus far in this box here, and I have to combine my like terms. So let's see, I'm going to do it down. I'll do it down here. I'm not sure what's going to happen. I forget on this one. So I got 2x squared minus x squared is x squared. And then I've got negative 8x plus 10x over here, which is 2x, positive 2x. And is there anything left? 2x, these two I've got, negative 8x. There is not a constant in this problem, so this is what I'm left with, x squared plus 2x. And if I take out an x, I won't have anything to cancel with here, so I can just leave it as x squared plus 2x. That's fine. Okay, and that's number 4. Okay, number 5. Let's see what we got here. Remember our rules here. I'm going to factor these. I guess I can get this denominator to be the same, but first I have to get them, I have to factor them. So this first one here is going to be what? How about x, same old game here. Bring down my plus sign. This is minus, and my two numbers would be 6 and 4. Okay, so that works. And this denominator here, this would factor to be x and x, minus and plus. And then we'll take a 7 and a 6 for these two fellas. Okay, so that means to get these denominators to be the same, it looks like, well, they both have an x plus a 6. So this one has x minus 4, this one has x minus 7, and this one does not. So let's multiply top and bottom by x minus 7. I'll just squeeze it in here and do it over here as x minus 7. Okay, and while we're at it, let's take care of this side here to make them the same. So I've got the x plus 6 and the x minus 7. It's lacking an x minus 4. And there's my x minus 4 for top and bottom. Denominators are the same, so now I want to multiply these two binomials on each side separately. So this one would end up being x squared minus 7x plus 8x minus 56, which simplifies to be x squared plus x minus 56. And then this side here, this numerator, after I FOIL that, that's going to be x squared plus 9x, I'll do the inside first, and then minus 4x minus 36, which now gives me x squared plus 5x minus 36. And now I have the joy and the pleasure of combining these two, because it's a plus sign in between. This plus sign is this plus sign. So when I add them together, I get 2x squared, and then I've got plus 6x minus, let's see, 56 and 36, that was the one, that's 92, minus 92. And that's all over the x minus 7, x minus 4, and x plus 6. And that was all my answer was. I took out, when I was doing this earlier, if I take out a 2, then I've got left is x squared plus 3x minus, what is that, 46. Then I can look at this one and say, well, if I can't factor this to two binomials, that'll give me any one of these three, and the denominator cancel out. So either one of these two are my answers for that. I could say or. All right, so that one is good. That's our answer. Number 6, solve the following equations for the variable. So I'm going to solve for x on this problem. And how do I start? Well, I guess I could, I guess I could practice what I preach and get rid of this fraction here by multiplying everything by the LCD, and the LCD here is x. So multiply all these terms by x and see what it simplifies to be. So it looks like it's going to be 8x plus 10 equals x squared plus 5x. I see the x squared, so that's telling me that's a quadratic equation. I'll have to factor that. So I'm going to get it equal to 0 by bringing the 8x and the 10 over to the other side by adding the opposite. That'll make it 0 on the left side. So if I subtract 8x over here and subtract 10, I end up with, I'll do it over here, x squared minus 3x minus 10. Now the question is, can I factor this? And it looks like I can. I can try anyway. I've got x here, minus, plus, what are my two numbers? 5 and 2. So it becomes when x equals 5 or when x equals negative 2. Either one of these are answers because it will not create a 0 in the denominator. So those are my solutions. Onward to the next one. A lot of you made the cardinal sin of not multiplying the 1 by the LCD to get them to be the same. So for example, this is 1 over x plus 7. When I factor this one, it's going to be what? X plus 7 times x minus 7. And therefore this one, to get it to be the same, the first one, I have to multiply top and bottom by x minus 7. X minus 7, like this. And then the 1 here I have to multiply by x minus 7 times x plus 7. Okay, I have to do the 1 as well. So now my denominators are the same. And well, let me say that again. Yep. And so now I'm going to combine my numerators. This is the same as, top and bottom here are the same without writing it. I can write it because it's equal to 1. X minus 7, x plus 7. Nevertheless, my denominators are still the same. And I can combine my numerators. So this would be x minus 7 plus 14 equals, and then I'll FOIL this back, and I know what it is. It's the sum and the difference of the same two terms, so it's x squared minus 49. Minus 49. Okay, there's my quadratic, so I'll get everything back over to the other side to make it equal to 0. So this is what? X plus 7. So I'm going to subtract x and subtract 7 from both sides. So it's going to be 0 equals this. Now when I combine my like terms, I've got x squared minus x minus 49 and 7 is 56. And now when I go to FOIL this, or factor it, here's my factorization. This looks familiar. Minus and plus. I've got what? 8 here, 7 here. So it's when x equals 8 or when x equals negative 7. However, if I plug in negative 7 into the denominator here in this original equation, you can see I get 0. So x equals negative 7 is technically not an answer. I just have one answer if x equals 8. Okay, that's number 7. Number 8. Let's get these denominators to be the same. So I'm going to multiply top and bottom here by a minus 10. A minus 10. Squeeze it in here. And then the a minus 10, I'll multiply top and bottom by a plus 6. Good. Denominators are the same. So now I've got what? A squared minus 10a, that equals negative 2a minus 12. That's this, doing the distributive property, of course. I got a squared, so get the equation equal to 0 by adding 2a and adding 12 to both sides. I can add 2a here and then add 12, I don't know, somewhere over here, plus 12. So the right side is 0. That equals this left side of a squared. What do I end up with here? Minus 8a plus 12. Okay, when I factor this, I got an A and an A, a minus and a minus, and the two numbers are what? 6 and 2 equals 0. So A equals 6 or A equals 2. Okay, now I can use the 6 here because 6 plus 6 is 12. And the 2, of course, I can use as well. So we're good. That's our solution for number 8. Number 9. Get these denominators again to be the same. Remember, this is over 1. So this, I can factor out the middle one here, take a 2 out, and I've got x minus 4. So what does this mean? This means the left side here, scratch that out, it bugs me sometime. I'm just going to multiply top and bottom here by 2. And then the 6, top and bottom, I have to multiply by 2 times x minus 4 over 2 times x minus 4. Okay, now I see that the denominators are all the same. So now I'll simplify my numerators. So let's see, what have I got here? I got 2 times 4 is 8 plus 4 equals, and then this is 6 times 2 is 12. 12 times x is 12x. And 12 times negative 4 is negative 48. Seems like we did this in class. I'm not positive. Okay, here's where we're at. And now I'm going to solve for x. So let's see, this is 12 here. If I add 48, I'll get the x working on by itself, the 12x first. So let me add 48. So this gives me 60 equals this 12x. So therefore, x equals 5. And again, I'm checking the 5. If it goes into the x in the denominator, will that create a 0? The answer is no. So we're good to go. Here's the infamous, hold on a second. Okay. Solve the equation for the indicated variable. Here is, a lot of us had a tough time with this, but I want to solve for u here, meaning I want to get u by itself here. So the easiest thing to do is get rid of the fraction, so multiply top and bottom here by s plus u. S plus u, or just, top. I'm going to clear this out. So I have to multiply both sides by s plus u. S plus u like this. Okay, so the s plus u's cancel on this side. You're stuck with 3r. That equals this s plus u times t. You could distribute it through, but you don't have to, because we want to get the u by itself. So then we end up factoring it out anyway. But in this case here, at this point in time, I want to I'll bring down the s plus u times t. Then at this point, I want to divide by t. Okay, so when I divide by t, I've got s plus u equals 3r over t. Now I'm solving for u, so that means I'm just going to subtract s from both sides. So u equals 3r over t minus s. And that's our solution. You have a different look to it. That's equivalent. That was fine as well. All right, that was number 10. Number 11, here we go. Another kind of gets redundant after a while. So in this one, I'm going to make the denominators the same. So this 8 needs an a minus 6, top and bottom. A minus 6. Okay, once that's done, now I can work on my numerator. And that's going to be what? 8a minus 48 plus 42 equals 7a. Okay, here I'm going to have 8a minus 6 equals 7a. Solving for a, let's see, I'm going to subtract 7a on both sides to give me a minus 6 equals 0. And I'll bring it up over here to say that a equals 6. However, if I substitute 6 into this equation, I'm going to get 0 in all the denominators. So therefore, this is empty set, or rather no solution for that one. Okay, moving on. Here I've got a job with getting the denominators to be the same, so it looks like my goal is to get everything to be 35x. So this needs a 7, top and bottom. This needs a 5x, top and bottom. And this needs a 7, top and bottom. I'm looking to see what I could make those all the same, and I multiply them all together, and that'll give you what you're looking for. With a 5 times 7 is 35, and then throw in the x there. All right, so my denominators are the same, clearly, and now I've got this to deal with. 7 times 19 is 133, plus 2 times 5x is 10x. That equals 9 times 7, which is 63. Okay. Oh, what do you think here? I am going to subtract 133. If I subtract 133, let's see, 133, I just subtract them like normal numbers. I got 0 and 70, but it is a negative 70, because negative 133, the absolute value of that is larger than 63. And now I can see that when I divide by 10 here, both sides, that x equals negative 7. And that's my answer for that. Here we go again with the variable, solving for the variable, this time for z. This is a little easier because I don't have the binomial in the denominator. So I'm going to clear the fraction, multiply everything by z. And when you do, I get bz equals fz minus p. The z's here just cancel out. All right, since I'm solving for z, I want to get the z's on the same side of the equal sign. So in this case, I want to subtract fz from both sides. So then I'm left with bz minus fz, that equals negative p. And now the big step here is to factor out the z, and you're left with b minus f. equals negative p. And last step, divide both sides by b minus f. And you end up with z equaling negative p over b minus f. There we go. Done with that one. Okay, you got number 14, solve the proportion. These here, we could make these denominators the same if we wanted to, or I can just cross multiply here. So I like to keep things consistent, make the denominators the same, but we're all about solving proportions, and this is the case. So I'm going to multiply 5 times x plus 5. So that's going to give me 5x plus 25 equal to, remember it's equal to, not, people were putting it underneath each other, making a fraction. That was not the case here. We're cross multiplying, and now I got my equal sign, and this is going to be 3 times 2x is 6x, which goes over on the right side of the equal sign, plus 27. So this is my equation by getting rid of the fractions, if you will. All right, now just solve for x. So it looks like I'm going to subtract 5x from both sides and subtract 27 while I'm at it. And I get negative 2 equals x. And if x equals negative 2, will that create a 0 in the denominator? It doesn't look like it, so that would be my solution for number 14. Find the unknown length. Variety of ways of doing this, but as I explained in class, to me this is 8 over 11. I see it as a 8 over 30. And it equals y over 7, taking the corresponding sides. Y over 17, that is. Okay, I could make life a little bit easier if I simplify this, because I know what 2 will go into both of these numbers. So 2 goes into 8 4 times, so I could do it over here 4 times, and 2 goes into 30 15 times. Okay, now make my proportion y over 7 equals 4 over 15. Now I end up with 15 crossing multiply, 15y, cross multiplying I meant to say, equals 17 divided by 17 times 4. So what is that? 40, 50, 68. Okay, 40, 50, 68. And now to get y by itself, I'll divide both sides by 15. So y equals 68 over 15. And you can see if that simplifies any. I don't think that one does. That does not. I don't have any common factors, so that stays as it is. Okay, got our nice problem here about the work problem. Sally can paint a room in 6 hours. Steve can paint a room in 8 hours. How long would it take for Sally and Steve to paint the room together? So we needed our formula of 1 over 6 plus 1 over 8 equals 1 over x. I'll solve for x, and that'll be our solution. So this one, what are we doing here? Getting our denominators the same, maybe. So let's see, what could I do there? Make them 24x. So I'll multiply this by 4x over 4x. The 8 by 3x over 3x. Make sure my writing's clear. And this x by 24 over 24. Uh, 24x over 24x. All right, then I've got 4x plus 3x equals 24. Seven x equals 24. divide by 7. So x equals 24 over 7. Or what was that? If I wanted to do it in mixed numbers, 7 into 24 goes 3 times. 3 times 7 is 21. 3 and 3, 7 hours. Yeah, they're going by hours. Next, Lisa and Don can clean a house together in 3 hours. If it takes Lisa 5 hours to clean a house alone, how long would it take Don to clean the house alone? Okay, so this looks like it's one of those where I'm going to have a 1 over something plus 1 over x that equals 1 over something. Okay, so Lisa and Don can clean a house together in 3 hours. So that's what they can do together. That's usually what we solve for. So this denominator here is going to be 3. If it takes Lisa 5 hours to clean a house alone, well, the first one here, Lisa, that's 1 over 5. How long would it take Don to clean the house alone? So this one's Lisa and this one's Don, and we're going to find out how long it takes Don to do it alone by solving this problem. So let's make all these the same, these denominators the same. 15x comes to mind. So I'm going to multiply this by 3x over 3x. That gives me 15x here. This one by 15 over 15. And this one here by 3x over 5x over 5x. So that gives me my denominators to be the same at 15x. My numerators now are going to be what? Let's see, let me dart it over here. So I got 3x times 1 is 3x plus 15 times 1 is 15. That equals 5x times 1, which is 5x. Now solving for x, I suppose I could subtract 3x here, both sides. And I've got 15 equals 2x. Therefore, x would equal 15 over 2, which equals 7.5 hours that it would take him to clean the house alone. Men are much smaller is the implication there. Men are much slower, I should say, not smaller. All right, last three, 18, 19, 20. Keep, change, flip. Keep, change, flip. -5 over 2x. Excuse me. I can do some simplifying here. I know my answer is going to be positive, so I can disregard that, really. I know it's going to be positive. A negative times a negative is a positive. And now, let's see, I got 2x goes into 2x once. 2x goes into 12x 6 times. 5 goes into 5 once. 5 goes into 25 5 times. So it looks like I just end up with 6 over 5. The x is canceled off. All right, that's 18. Number 19 here. This was a little stinker. All right, so let's see. I'm going to determine what the denominator is first. All right, so let's see. What have I got here? To make them the same, I'll multiply this one by q over q, and this side by p over p. And that makes this the denominator over here, it makes it q plus p over pq or qp. That's indicating multiplication. And the 4 I could write as 4 over 1. Now if I do the keep, change, flip thing, it's going to be, I'll do it down here, 4 over 1 times PQ over Q plus P. And that gives me 4 times PQ. It's not the distributive property, if that's what you were thinking, over Q plus P, or any variation of this too. I really didn't have to put that in parentheses, but this is that's okay. Okay, could have just been 4PQ. That's fine. All right, one more to go. I've got 1 plus 9 over 49. So the easiest thing to do here is make this 1 equivalent to 1 with this denominator 49. So it'd be 49 over 49. And that's going to give me what? 49 plus 9 is 58 over 49. And the bottom I'll do the same thing. Wonder if I should keep going on, or I'll just do it here. So this one I'll multiply top and bottom by 7. And that gives me 7 in the denominator, and 7 times 1 is 7, minus 3 is 4. So I got the keep, change, flip thing going. So I've got keep the first one, change the sign to multiplication, and flip this. This will be 7 over 4. 7 goes into 7 once, 7 into 49, 7 times. 2 goes into 4 2 times. And 2 goes into 58. Let's see, what is that? 29 times? 29. All right, see what I end up with? 29 times 1 is 29 over 7 times 2. 7 times 2 is 14. And there we're done with that. All right, there was the test 3A, I think this was. Yeah, okay. Thank you very much.